2026 A-Level Combined Mathematics Paper 1 Part B, question number 17, Part B. Part A of this same question was discussed in a previous video, link in the top right, and Part C of this question will be discussed in future video, link in the top right. Part B of this question has to do with the cosine rule. The first part of the question says, in the usual notation, state the cosine rule for a triangle ABC. The question then says, in a triangle ABC, the point D lies on the line BC such that the ratio of the lengths BD to DC is 2:1. Now given this, they ask us to apply the cosine rule for suitable triangles and show that in the usual notation, the length AD squared is equal to 109 times 6b squared plus 3c squared minus 2a squared. The question then finally says, if the length AB is 3 centimeters, AC is 2 centimeters, and the length AD is root 37 over 3 centimeters, show that the angle BAC is equal to pi by 3 radians. Now to start off with this question, let's draw a triangle ABC in the usual notation. Now given a triangle like this with vertices of capital A, capital B, and capital C, the side lengths opposite to those vertices will be labeled as simple A, simple B, simple C, and the angles at each of the vertices will be labeled by the same symbol of the vertex. So the angle here will be labeled as capital A, the angle here will be labeled as capital B, and the angle here will be labeled as capital C. Now given this setup, the cosine rule states that for any side length, let's say C squared is equal to the sum of the other two side lengths squared, so A squared plus B squared, minus 2 times the product of the side lengths, so A times B, times the cosine of the angle between those two side lengths, which for A and B is going to be the angle capital C. So minus 2AB cosine capital C. Now similarly, it also states that B squared would be equal by the same logic to A squared plus C squared minus 2AC cosine of capital B, and that A squared would be equal to B squared plus C squared minus 2BC cosine of capital A. Now when stating the cosine rule, you don't have to write all three of these just one, but since I've already written them, I'll leave all three as what the cosine rule states. So the cosine rule states that any side length C squared will be equal to A squared plus B squared minus 2AB cosine of capital C. Now given this, the question then says, in a triangle ABC, the point D lies on the side length BC such that the ratio of BD length to DC length is 2:1. Now going down, let's consider a triangle like that, a triangle ABC in the standard notation, where the side length BC, which I'll take as the bottom side length here, is broken in the ratio of 2:1. So that means that the point D will be somewhere approximately over here. And according to that, the length AD will be represented by this line right here. Now marking out the points, we can see this point is A, this point is D, this is B, and this is C. Then the side length here, which is opposite to this length C, or rather the vertex C, will be the length simple C, and this side length here opposite to B will be simple B, and the total side length here BC will be represented by simple A. However, since this is broken in the ratio of 2:1, we can say if the total length is simple A, then the length BD, which is 2/3 of that, will be 2/3A. And similarly, the length DC will be 1/3A. So therefore, we get the length BD being 2/3A and the length DC being equal to 1/3A, where A is the total length BC. Now given this, they say, by applying the cosine rule for suitable triangles, show in the usual notation that AD squared is equal to 109 times 6b squared plus 3c squared minus 2a squared. Now for this one, out of the three triangles in this diagram, the triangles ABD, ABC, and ADC, we have to choose at least two of them and make the cosine rule equations, and then using them, we have to cancel out unwanted terms and get the length AD. Now in this case, I can see I can get the required equations by just using the triangles ABD and ABC by taking the common angle of B in both of these triangles and applying the cosine rule such that the angle at the point B is the angle that goes into the cosine in both of those cases. So considering that, I'll say applying the cosine rule, and I'll apply it for the triangle ABC and also for the triangle ABD. And in both of them, I'll be applying them for the angle B. I'll be applying them such the angle B goes into the cosine. Now, corners that we can see for the triangle ABC, the side length opposite to B is simple B, and therefore we'll get B squared equals A squared plus C squared minus 2AC cosine of capital B. Now for the triangle ABD, if we take a look, we can see the side length opposite to the angle B in this triangle is the side length AD, and therefore when we make the cosine rule, we'll have to take AD as being the opposite side length. So then we'll get AD squared being equal to the other two side lengths squared, which is going to be C squared, and 2/3 of A squared, so we can write 2/3 of A whole thing squared plus C squared minus 2 times the first side length of 2/3 of A times the second side length of C times the cosine of the angle between them, which is the angle capital B. So times the cosine of capital B. And I'm going to call this equation equation 1 and this other equation equation 2. Now in the question they have AD squared being equal to 1/9 times 6B squared plus 3C squared minus 2A squared. Now importantly here, they have the side lengths AB and C in the equation, but they don't have the cosine of capital B. So therefore we can see, since in our equations all we have is AD, AB and C, and the cosine of capital B, if we substitute for capital B, cosine of capital B, into this equation, we can get rid of the cosine of capital B and get an equation for AD squared in terms of only simple A, simple B, and simple C. So that is what we're expected to do. Now to do that, what we can do is to first take equation number 1 and rearrange it to make cosine of B the subject. Now doing that, we can see if we take this A squared and C squared to the other side, we'll get B squared minus A squared minus C squared equals minus 2AC cosine of capital B. And rearranging, we can see we can get cosine of capital B being equal to B squared minus A squared minus C squared divided by negative 2AC. I'm going to call that equation number 3. Now from this we can see if we substitute equation 3 into equation 2, we'll be rid of the cosine of B and can therefore have an equation for AD squared in terms of only A, B and C. Now doing so, if we do 2, 3, we will get on the left hand side AD squared being equal to 2/3 of A whole thing squared, which is going to be equal to 4/9 A squared, 4/9 A squared plus C squared, and then we have minus 2 times 2/3 of A times C, which I'll write as plus 2/3 of minus 2AC times the cosine of capital B, which is equal to B squared minus A squared minus C squared divided by minus 2AC. Now from this we can see if we cancel out the minus 2AC here and here, since the lengths A, B and C are not 0, we can see we can cancel these two out without a problem, and then we get AD squared being equal to 4/9 A squared plus C squared plus 2/3 times B squared minus A squared minus C squared. So we get plus 2/3 of B squared minus 2/3 of A squared and minus 2/3 of C squared. So that's the equation we get. Now in this equation, we can see in the equation they gave us in the question, they had a 1/9 factored out. So we'll do the same thing. We'll take this equation and we'll take a 1/9 as a factor and write that AD squared is equal to 1/9 times whatever's on the inside. Now on the inside we can see we have 4a squared, a c squared here which has to be turned to 9c squared by multiplying and dividing by 9, a 2/3 b squared which has to be turned into 2 times 3 divided by 3 over 3 b squared, a minus 2/3 a squared which has to be turned into 2 times 3 divided by 3 times 3 a squared, and a minus 2 over 3 c squared which has to be turned into 2 times 3 divided by 3 times 3 c squared. Now from that we can see if we take out all of these 9's as common factors, we will get a 4a squared here and a minus 6a squared here for a total of minus 2a squared, and then we'll have a c squared here which is going to be 9c squared and a minus 2 over 3c squared which is going to be minus 6c squared for a total of 9 minus 6 or plus 3c squared, and for the b squareds we'll have 2 over 3b squared which turns into 6 over 9b squared. So then we get 6b squared times 1 over 9 on the outside. So as a final term we get 1 over 9 times 6b squared plus 3c squared minus 2a squared. So therefore, we get the equation AD squared equals 1 over 9 times 6b squared plus 3c squared minus 2a squared, which was given in the question. So with that, we're done with that part of the question. Now finally the question says, if AB is equal to 3 centimeters, AC is equal to 2 centimeters, and AD is equal to the square root of 37 over 3 centimeters, show that the angle BAC, which is this angle represented by capital A, is equal to pi by 3 radians. Now to do this, what we'll do is to take this equation that we just found and substitute in the known values. Now in the triangle, we know AB is 3 centimeters and AC is 2 centimeters. Now in the triangle AB is C, so we get C being equal to 2. So going down, if AB is equal to 2 centimeters as given in the question, or rather 3 centimeters as given in the question, if AB equals 3 centimeters, then the value C equals 3 centimeters. And similarly, if we get AC equal 2 centimeters, since AC is simple B, AC equal 2 centimeters means that simple B is equal to 2 centimeters. Now finally, if we have AD being equal to, what was the value? Root 37 over 3 centimeters, then we can see we substitute root 37 over 3, right? Yeah, root 37 over 3 centimeters, root 37 over 3 centimeters, then we can see by substitution, we'll get on the left hand side AD squared over root 37 over 3 squared being equal to the right hand side of 1 over 9 times 6 times b squared, which is 2 squared, 6 times 2 squared, plus 3 times c squared, which is equal to 3, so 3 times 3 squared, minus 2 times a squared, which we don't know the value of. Now from this we can see if we simplify, we'll get 37 divided by 9 being equal to 1 over 9 times 6 times 4 or 24 plus 3 times 3 squared, which is 9, so 3 times 9 is 27, so plus 27 minus 2a squared. And simplifying, we can see we cancel the 1 over 9's here, we get 37 on the left hand side, so 37 equals 24 plus 27, which is equal to 51 minus 2a squared. And rearranging, we can see we get 2a squared being equal to 51 minus 37, which is equal to we have 51, which is 11 minus 7, which is 4, so we have 14, which gives us that 2a squared is equal to 14, so a squared is equal to 7, so a is equal to the square root of 7, and with that we have found the length of a as well. Now with this information, in order to find the angle BAC, what we will do is to go down, consider the triangle ABC and apply the cosine rule to the triangle with the subject angle being the angle BAC, which is this angle right here. Now doing so, we can see the opposite side length will be the side length simple lay. So for that, let's go down and say applying cosine rule to the triangle ABC, and if we apply it with the angle BAC as the subject, we'll get A squared being equal to B squared plus C squared minus 2BC cosine of the angle, which is the angle BAC. I could label it capital A, but for the purpose of the question, I'll label it as BAC. Now, if we substitute, we can see A squared is equal to 7. On the other side, B squared, if B is equal to 2, B squared is equal to 4. So we have 4 plus C squared, which is equal to 3 squared, which is equal to 9. So plus 9 minus 2 times 2 times 3 times the cosine of the angle BAC. Now simplifying, we can see we get 7 minus 4 minus 9, which is equal to minus 6, which is equal to minus 2 times 6, or minus 12 times the cosine of the angle BAC. Now from that, we can see if we rearrange, we get cosine of BAC being equal to minus 6 divided by minus 12, or 1 over 2. So the cosine of BAC is equal to 1 over 2, which is also equal to the cosine of pi by 3. Now from this, we can directly say angle BAC is therefore equal to pi by 3, and we can directly say this because it's the cosine and because our angle BAC is in between 0 and pi radians. So we can say because angle BAC between 0 and pi radians, if the cosine of BAC is equal to the cosine of pi by 3, then BAC must be equal to pi by 3. And with that, we're done with the question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you draw the triangle ABC in the usual notation and then write the cosine rule, writing one of these three will get you 10 marks. You don't need to write all three. If you write all three, you still get the 10 marks, but you only need to write one of them. Now after that, when you then go down, draw the triangle given in the question and then apply the cosine rule for 2 out of the 3 triangles like so. For applying the cosine rule correctly, you get 10 total marks. After that, when you find either the cosine of B or the cosine of C like this and then substitute, for substituting the angle to get rid of it, you get 5 marks. After that, when you simplify down and eventually get AD squared equals the given expression, you'll get another 5 marks. Now from that, when they then give you the values of AB, AC and AD, when you substitute each of these 3 values incorrectly into the expression that you just found, you'll get 10 total marks for substituting correctly. After that, when you simplify down and get A, when you get A squared equals 7 and then A equals root 7, you'll get another 5 marks. And from that, when you finally apply the cosine rule to the triangle ABC to get this equation with the cosine of BAC angle, and then you simplify, for substituting in like this and simplifying, getting this kind of point gets you 5 marks. And after that, when you get cosine of BAC equals 1/2 equals cosine of pi by 3, and then conclude that BAC must be equal to pi by 3 as within the range of 0 to pi, the cosine is 1 to 1. So from that, when you get the final answer, you'll get another 5 marks. And with that, we're done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.